how to write a electron configuration. B. Orbital diagram. For 1. Phosphorus. 2. Astatine. Astatine 33. Phosphorus 15. Before we can or we have made the orbital diagram or the electron distribution at the outer principal quantum number, we must be able to make what is the electron configuration of each element. 1. Phosphorus 15 equals 1s, 2s, 2p, 3s, 3p, 4s, 3d. We must be able to distribute 1/5 amount of electrons in each amount of subshell. 2, 2, 6, 2, 3. We can have make 6 electrons can have exist at the outer principal quantum number that can be able to fill 2 electrons from S subshell and 3 electrons from P subshell. Then orbital diagrams can have explains for S can have 1 orbital that can have carry only 2 electrons, and P can have carry until 6 electrons. Until 3 orbitals that can have carry 6 electrons, because each amount of orbitals can have carry only 2 electrons that can have spin in either clockwise direction or counterclockwise direction, and d orbitals can have carry until 1, 0 or 10 amount of electrons and can have carried by 5 orbitals, and f orbitals can be able to carry until 1, 4 or 14 electrons that can be able to carry or carried by 7 orbitals. Then orbital, this is an electron configuration. Electronic configuration or distribution. But orbital diagrams can have expressed in terms of the chemical properties that can be able to determine at the outer principal quantum number. So phosphorus can have 6 electrons that can have exist at the outer principal quantum number determines for the chemical property of elements or chemical reaction of elements. Zone 2 electrons can have existed at S subshell and 3 electrons can have existed at P subshell. Then orbital diagrams can have expressed for 3s electrons can have existed and 3px, 3py, 3pz electrons that can have number of electrons, and orbitals can have revolved around x direction, y direction and z direction. So 2 electrons can have existed at s orbital that can have revolved either clockwise direction or counterclockwise direction, and 3 electrons can have distribute at 3px, 3pz and 3py that can have equal energy or degenerated orbitals. Degenerated orbitals. Three degenerated orbitals that can have an orbital that can be able to exist in 3 directions can be able to distribute in equal amount of electrons, because 2 electrons cannot be able to revolve at px direction, but 3 electrons can be able to distribute in x direction, y direction and z direction, because p px direction, py direction, and pz directions can have equal energy or degenerated orbitals because of amount of electrons can be able to attracted by equal energy. So it is orbital diagram, electron configuration. So, astatine 33 atomic number. Number of electrons can have distributed 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 2, 2, 6, 2, 6, 2, 10, 2, 10, 12, 18, 20, 30, and 3. Electron configuration. An electron configuration of astatine. Outer principal quantum number of electrons can have revolve at 4p. Number of chemical property of astatine can be able to determined by s orbitals that can have existed at the 4th principal quantum number and at 4p principal quantum number that can be able to carry at only 3 electrons. But orbital diagrams can be able to determine at the outer principal quantum number. So orbital diagrams can have expressed in terms of 4s that can have only one orbital and 4p that can have consist 3 orbitals that can have carry equal amount of electrons. Then s can have carry 2 electrons. So 2 electrons can have carried or filled by s electrons. P can have carry 3 electrons, 1 electron from px, 2 electron from and z electron. Is orbital diagram, electron configuration. Orbital diagram, electron configuration.